Imagine walking into a lab and seeing a scientist holding what looks like an ordinary rock. But then, with a wave of a magnet, something extraordinary happens. The rock actually gets colder. Not just a little, but enough that you could measure the temperature drop with scientific instruments. It's the kind of moment that makes you question everything you thought you knew about the laws of physics. Rocks are supposed to be boring, right? Just sitting there minding their own business? But this one? It's about to flip the script on what we know about matter, energy, and the very nature of cooling itself. Welcome to Science with a Plot Twist. Today we're diving into a story that sounds like it was ripped straight from a science fiction novel, but it's happening right now, in real-world labs. This is the tale of a crystal that doesn't just break the rules, it rewrites them. So buckle up, because what you're about to learn might just change the way you think about the world around you. Let's start with a quick science rewind. In most cases, when you put a material, say a piece of metal or a special kind of crystal, into a magnetic field, something predictable happens. The atoms inside start to jiggle around more, and the material heats up. This is called the magnetocaloric effect. It's a well-known phenomenon, and it's actually the principle behind some of the most advanced refrigerators in the world. Instead of using chemical coolants, these fridges use magnets to manipulate the temperature of special materials, making them heat up or cool down as needed. It's a clever trick, and it's already being used in cutting-edge technology. That's the magnetocaloric effect in action. When you apply a magnetic field, the material's magnetic moments, tiny compass needles at the atomic level, line up, and the system releases heat. Remove the field, and the material cools down as the moments become disordered again. This cycle is the backbone of magnetic refrigeration, which is more efficient and environmentally friendly than traditional methods. But here's the thing. In all these cases, the material first heats up when the magnet is applied. That's the rule. Or at least it was. But recently, a team of physicists stumbled upon something that defied this rule. They were working with a crystal that seemed ordinary at first glance, but when they put it in a magnetic field, it didn't heat up. Instead, it cooled down, and not just by a tiny fraction of a degree. This was a real, measurable drop in temperature. It was as if the crystal was saying, "Nah, I'm gonna do my own thing." This wasn't just a minor anomaly. It was a discovery that sent shockwaves through the scientific community. Meet YB2T207. That's short for ytterbium titanate, and yes, it's a bit of a tongue twister. But this crystal is more than just a mouthful. It's a total rule breaker. YB2T207 is part of a family of materials known as rare earth pyrochlores, and it's been the subject of intense research for years. Scientists suspected it might have some unusual properties, but nobody expected this. When exposed to a magnetic field, instead of following the crowd and heating up, YB2T207 cools down. It's like the rebel of the material world, refusing to play by the established rules. So what makes this crystal so special? Scientists call it a frustrated magnet. Now that doesn't mean it's having a bad day or listening to sad music in its room. In physics, frustration is a technical term. It means that the magnetic moments inside the crystal, the little atomic compass needles, can't all line up in a way that makes them happy. The geometry of the crystal forces them into a kind of stalemate, where no arrangement is perfect. It's like trying to seat a group of friends at a table where nobody wants to sit next to each other. No matter how you arrange them, someone's always unhappy. This frustration leads to something truly bizarre. Instead of settling into a neat, orderly pattern, the magnetic moments are constantly shifting, unable to agree on a single arrangement. They're in a perpetual state of motion, a kind of quantum dance that never stops. This is what physicists call a quantum spin liquid, a state of matter where the spins are always fluctuating, even at temperatures close to absolute zero. It's a bit like a dance party where nobody ever sits down and the music never stops. The result is a material with properties that are almost impossible to predict using classical physics. In the lab, scientists use powerful computers and advanced imaging techniques to try to make sense of what's happening inside these crystals. They watch as the spins wiggle and shift, creating patterns that are both beautiful and bewildering. It's a window into the strange world of quantum mechanics, where the rules are different and intuition often fails. The discovery of a crystal that cools itself in a magnetic field is more than just a curiosity. It's a glimpse into a new frontier of physics, where the boundaries of what's possible are constantly being pushed. Here's the wild part. When researchers cranked up the magnet, instead of the crystal heating up like every other material, it actually cooled down. And this wasn't just a fluke. The effect was repeatable, measurable, and consistent. Using infrared cameras and sensitive thermometers, the scientists watched as the temperature of the crystal dropped in real time. It was as if the crystal was pulling heat out of itself, defying the expectations of everyone in the room. This phenomenon is now being called the inverse magnetocaloric effect, and it's opening up a whole new area of research. The implications of this discovery are huge. For one thing, it challenges our understanding of how energy and magnetism interact at the quantum level. But it also has practical applications that could change the way we build technology. Imagine a refrigerator that doesn't need harmful chemicals or bulky compressors, just a small piece of crystal and a magnet. Or think about cooling systems for quantum computers, which need to operate at incredibly low temperatures to function properly. This new effect could make those systems smaller, cheaper, and more efficient. It's like nature's version of air conditioning, but way cooler. Instead of relying on traditional methods that use a lot of energy and can be harmful to the environment, this crystal offers a glimpse of a future where cooling is cleaner, greener, and more efficient. The potential applications are almost limitless, from keeping our homes comfortable to enabling the next generation of supercomputers and medical devices. Why does this matter? Well, as our technology gets more advanced, the need for efficient cooling becomes more and more important. Quantum computers, for example, are incredibly powerful, but they generate a lot of heat and need to be kept at temperatures close to absolute zero. MRI machines, which are used in hospitals around the world, also rely on super cold environments to function. If we can harness the power of crystals like YB2T207, we could revolutionize these fields and many others. Super cold technology is the secret sauce for some of the most exciting advances in science and medicine. Quantum computers could solve problems that are impossible for classical computers, opening up new possibilities in everything from cryptography to drug discovery. MRI machines provide detailed images of the inside of the human body, helping doctors diagnose and treat diseases more effectively. All of these technologies depend on our ability to control temperature at the smallest scales. And that's where this new discovery comes in. If we can figure out how to harness the inverse magnetocaloric effect, we might be able to build cooling systems that are smaller, cheaper, and more efficient than anything we have today. Imagine a world where your laptop never overheats, your phone stays cool even during heavy use, and massive data centers can run at full power without worrying about temperature spikes. The possibilities are endless, and it all starts with a tiny crystal and a big idea. So yeah, crystals aren't just for vibes or new age shops. They might actually help us chill out, quantum style. The next time you see a shiny rock, remember, it could be the key to the future of technology. And who knows, maybe one day the device you're watching this on will be cooled by a crystal that breaks the rules of physics. Stay curious, stay cool, and hit subscribe for more science that breaks the rules. Because in the world of physics, the most exciting discoveries are the ones that surprise us. And sometimes, all it takes is a crystal with a mind of its own to change everything.